In this lesson, we are going to be looking at multiplying rational expressions. So here's the first thing that you're going to do. Basically, all you're going to do is reduce these. The one thing you need to be conscious of is that you can never have 0 in the denominator when you have a fraction. So you have to think about values that would make your denominator 0, and we'll talk about that in a minute. But for this one, all you really need to do is think about reducing this. So 21 over 14, if you think about that as a fraction, obviously reduces to 3/2. So you'll have a 3 in the numerator and a 2 in the denominator. The 2x squareds are going to cancel out. And then one of these y's will cancel with one of these, and it'll make that a 2 in the numerator. Or, yeah, y squared in the numerator. So you'll have that. Okay, but in your original expression, right here, if x is 0, that would make 14 times 0 times, it doesn't matter what y is, your denominator would be 0. If y is 0 right here, again, that would also make your denominator be 0, because 14 times, it doesn't matter what x is, times 0 would be 0. So this is your simplified expression, except for you need to be conscious of the fact that x can't be 0 and y can't be 0, because it would make your denominators be 0, which is, of course, you can't divide by 0, so that's illegal. Okay, here's kind of another one. You can square everything first and then reduce, or you can reduce and then square. It doesn't really matter. I am going to square everything first, just because that's sort of the order of operations. So when we square the numerator, you have to square 5 and get 25. These exponents will be multiplied, and so you'll have x to the 4th, y to the 1 times 2 is 2, and z to the 3 times 2 makes 6. In the denominator, 10 squared would be 100. X to the 4 times 2 would be 8, and z to the 1 times 2 would be z squared. Okay, so here's where I'm at right now. And again, you want to be conscious of the fact that right here, your x can't be 0 because it would make your denominator be 0. And right here, z can't be 0 because it would make your denominator be 0. And that is illegal, so just be aware of that. We'll come back to that in a minute. If I reduce 25 over 100, obviously I have a 1 on the top and the 4 on the bottom. I'm not going to write the 1 for right now. If you look at your x's, you have 4 x's here, which can cancel with 4 of those out and make that be x to the 4th in the denominator. You only have y's on the top, so you would have y squared up there. And then z to the 6th over z squared, you have 2 of these, which will cancel with 2 of those and make that be a 4 on the top. So this is what it looks like simplified. However, again, be aware that because this is right here, x cannot be 0, and because of this right here, z can't be 0, or those would make your denominators be 0, and that is not legal. All right, and now we're going to get into the actual multiplying piece here. Again, when you're multiplying things, you can cancel them out up down, or you can cancel them out kitty corner, just to remind you of those little rules. Problem here, y can't be 0, because that would make that fraction have a denominator of 0, and right here x can't be 0 because that fraction would have a denominator of 0. And now you're going to cancel. All right, so I can cancel this 8 with this 16 and make it be a 2. I can cancel one of these x's, that x, with one of these and make that be x squared. And then, of course, the 7 can become a 1, and the 21 can become a 3. And then I can cancel both of those y's with 2 of those and make this be y to the 1. So, a little bit confusing, but on the top, when you multiply this across, the only thing you have left is 1. And on the bottom, what you have left is this 3, this y, this 2, and this x squared. So on the bottom, 3 times 2 makes 6, and then you have x squared, and you have a y. Okay, and we already know that x can't be 0. We already talked about that, and that y can't be 0. And that's how that goes. All right, similarly here, I will try to write this a little bit better, but the 5 can become a 1, and the 15 can become a 3. This a to the third will cancel out with 3 of these and make this be a to the 1. The 12 and the 24 can reduce, be a 1 and a 2. These two b's here and here can cancel each other out. Okay. And then that is all I can do. So on the top, I have I have this 1 right here, and then I have an A, and I have a C, and I have a 2, and I have C squared. Okay, so 1 times 2 is 2, and then you have an A, and then you have C times C squared, which is C cubed. On the bottom, you have 1 times 3, which of course is 3, and then you have B squared. Okay, so right here, B can't be 0, and same thing here, B can't be 0 here, and here your A can't be 0 either. Okay, so A can't be 0, and B can't be 0. All right, moving on. Okay, first of all, what we're doing is we're canceling whole entire expressions right here. So these two right here can cancel. First of all, I want you to pay attention, though I should have talked about this first before I started canceling. For this quantity right here to be 0, if y plus 7 is 0 and I solve it, then of course y would be negative 7. So if I plug negative 7 in for y, that makes that expression be 0. And if that expression is 0, no matter what I multiply it by, the whole denominator is 0. So because of that, y can't be negative 7. And right here, when you think of y squared minus 9 being 0, obviously y squared is 9. And then y would either be plus or minus, well, y would be the square root of 9. So then y is either plus or minus 3, positive or negative 3. So y can't be 3, and y can't be negative 3 here, because if I square 3, 3 squared is 9, 9 minus 9 is 0. If I square negative 3 squared is 9, minus 9 is 0. Okay? Then, back to our problem. These two can't cancel. Okay? And I have the 3y left on top, and I have the y squared minus 9 left on the bottom. And y squared minus 9, you can leave it like that if you want. And the reason you can leave it like that is nothing cancels. Or you might want to get into the habit of realizing that that's a perfect square, which factors as y plus 3 and y minus 3. Either way you want to do this, nothing cancels when I factor the y plus 3 and y minus 3, so it doesn't really do me any good to factor it, but many times something will cancel and you'll want to be aware of that. We already talked about how y cannot be 3, y cannot be negative 3, and y cannot be 7, because all of those quantities would make denominators be 0. All right, here now you have to kind of get used to factoring and then canceling. Okay, so here we go. This top one factors, if I pull a 5 out of there, then that factors as 5 times y minus 2. In the bottom, I can pull a 15y out of there, and if I pull a 15y out of there, then I have y minus 2 again. Okay, so now I'm here. I'm just going to write this so that it becomes a little bit less confusing. I have not changed anything. I am just recopying this with what I have left on top after I have factored it. Okay? Now, pay attention to your denominators at this point. Right here, y can't be 0, because that would make that be 0. And then if you take this quantity right here, y can't be positive 2, because 2 minus 2 would make that be 0, and that's not going to work. Okay? So this will cancel with this. And then, of course, the 5 becomes a 1, and the 15 becomes a 3. So all you have left on top then is 1, and all you have left on the bottom is 3, and then this y that's right here. So you have 1 over 3y, and we already know that y can't be 0, and y can't be 2. And that's how that one works. All right, a few more here. All right, we are going to, on the top, factor out an a to the 4th. And then you will have b minus 2 on the top. On the bottom, you will have a to the 3rd that you can pull out. And then you will have 2 minus b. Okay? All right, first of all, I want to pay attention to the fact that right here, your a cannot be 0 because 0 times anything would be 0. And then if you set 2 minus b equal to 0, 2 would be b. So b can't be 2 either. Okay, so those two things we know cannot happen. All right, now I'm just going to recopy what I have left, which is this right here over this right here. Okay, so I'm just going to recopy that. And what I want you to notice is what's in the numerator and the denominator. In the numerator, this is a positive b and a negative 2. In the denominator, this is a positive 2 and a negative b. So even if I switched these two guys around right here, if I switched them around, then I would have negative b plus 2. Okay? Notice, again, still the opposite signs. Positive b, negative b. Negative 2, positive 2. So the way to get the numerator and the denominator the same is instead of factoring a positive a to the 3rd out, factor a negative a to the 3rd out. If I factor a negative a to the 3rd out, then I would have a positive b and a negative 2, and they will end up being the same. Okay, so that's what I'm doing right there. Okay, then what happens is these b minus 2's cancel, and a to the 3rd here cancels with 3 of these here and makes that be a 1. And then of course you have this negative sign left down here. So on the top you have a to the 1, and on the bottom you have a negative 1, which of course you're going to just simplify as negative a. Okay? And then we know, of course, that a, we already talked about, a can't be 0 and b can't be 2. Okay? All right, a couple more here. This one, you should be able to factor a 2x squared out. So I will factor a 2x squared out of here, and that will leave me with x plus 6 on the top. And on the bottom, I want to obviously try to get x plus 6 so that it has something to cancel with. You can see that this is negative right here. So I will factor out a negative 6xx. Sorry, I can pull out a negative 6x out of there. And then if I pull a negative 6x times a positive x, gives me negative 6x squared. And then plus 6. Negative 6x times a positive 6 gives me negative 18. Okay? So these two will cancel each other out. And by the way, I should point out that right here, x can't be 0, and x also can't be negative 6. Okay? But those two cancel each other out. The 2 can become a 1, and the negative 6 can become a negative 3. And then this x can cancel out with one of those and make that be x. Okay? So on the top of that whole mess, all I have left with is x, and on the bottom, I have negative 3 left. And you might want to write that as negative x over 3. That's fine. It doesn't really matter. And I just totally messed this up, didn't I? These should be 3's right here. Sorry. 2 times x plus 3 makes a 2x cubed plus 6x squared. And then, oh my gosh, I'm sorry you guys, x can't be negative 3 right here. Okay? So x can't be 0, and x can't be negative 3. Sorry. All right, moving on. Okay, now we get to factor by undoing the FOIL. And so hopefully you remember how to do that. On this one, this factors, you know that x times x makes your front, and you have to have two numbers that multiply to make 6. They will be 2 and 3. You need to have a -3 and a +2 in order to undo the FOIL on that, and hopefully you're remembering how to do that. Okay, on the bottom, x times x makes x squared. 1 times 3 makes 3. Positive right here means they either need to be both plus or both minus. Since you have a positive here, it'll be plus plus, and that's that one. And then over here, we have x and x make x squared. You're back. 1 times 2 makes 2. And of course, since it's plus right here, it either needs to be plus plus or minus minus. Plus in the middle, so it'll be plus plus. And then over here, we have x times x. And then to make 15, it could be 1 and 15 or 3 and 5. I am going to try 3 and 5. When it's a plus right here, it either needs to be plus plus or minus minus. Because there's a minus right here, it will be minus minus. And then check your outsides. -5x and -3x does make -8x in the middle, which is what you need to happen. Okay, so now I'm going to stop right here and realize that no matter what happens, right here, x can't be -1. Right here, x can't be -3. So I'm going to just start my list. X can't be -1. X can't be -3. Right here, x can't be +3. And right here, x can't be +5. All of those would make denominators of 0, which is not going to work. Okay? So now let's look at this. We have an x minus 3 right here that could be canceled with an x minus 3 right here. And we have an x plus 1 here that can be canceled with an x plus 1 here. And then on the top, we have two x plus 2's left. So I have x plus 2 times x plus 2. And on the bottom, I have an x plus 3 here and an x minus 5 there. And sometimes you could leave your answer like that if you wanted, or if you wanted to make that just be a little bit prettier and FOIL the top out. So on the top you'd have x squared as your first. I'd have x squared, and then I have 2x and 2x put together, which makes 4x. And then your backs, 2 times 2 is 4. And then of course down here, x times x is x squared. Your outsides are -5x, your insides are 3x. Put that together and you get -2x. And then your backs, 3 times -5 would be -15. And the same rules still apply. X could not be -1, x could not be -3, x can't be +3, and x can't be 5. So if you would rather write your answer like that, that is totally fine too, whichever way you prefer it. And one more, and we are done. So, on this one, let's see. You can factor this as, let's see, on this one, I can factor this guy as 3x and x. And on the back, 6 can be 2 and 3, or 1 and 6. I am going to make this be 3 and 2 right here. You can do it however you want. Now, if you check your outsides, you have 9, and you check your insides, you have 2, and 9 plus 2, of course, does make 11. Plus and plus right here. All right, down here, I can factor 4 out, and then I will have x squared minus x minus 2, which that then factors x times x makes x squared. 1 times 2, a negative and a positive. So that's where that's at. And then up here, I can pull a 2 out, and I will have x squared minus 3x plus 2, which then that factors as x like this. And then in your back, the only way to get 2 is 1 times 2. If it's a plus back here, it either needs to be plus plus or minus minus. This one will be minus minus. And then over here, we have x and x to make our fronts, 1 and 3 to make our backs. If it's a minus at the end, you need to have one of each, and I will need to have a positive 3 and a negative 1. All right. Now, here we go. We are going to reduce, and I am going to cross this out so this isn't confusing me, and I'm going to cross this out so that's not confusing me. Okay? All right. Now, I have an x plus 3 here that can cancel out with an x plus 3 here. I have an x minus 1 that can cancel with an x minus 1. I have an x minus 2 that can cancel with an x minus 2. And then I have a 2 and a 4 that can cancel. So on the top, all I have left is this 3x plus 2. And on the bottom, I have this 2 left and this x plus 1 left. Okay, now, if you look at this right here, x can't be negative 1. Right here, x can't be 2. Right here, x can't be positive 1. And right here, x can't be negative 3. Okay, so there you go. And if you wanted to multiply that bottom out and make it be 2x plus 2, that is completely fine too. All right?